Alright, in this video clip we're going to take a bar modelling approach at solving GCSE questions like the ones you can see in front of you there. But before we come to look at the past paper questions, we will take a look at some practice questions. So question 1. An aquarium contains 80 tropical fish. Some are tetra, some are rainbow, and the rest are angel. So question 1. Tetra, rainbow, angel. There are 3 times more angel fish than tetra fish. So if we take the tetra fish as one block of our bar, there are 3 times more angel. So angel will be a bar that's 3 times as big. And there are 10 fewer angel fish than rainbow fish. So that means there are more rainbow fish than angel fish. 10 more. So for the rainbow fish, that represents the angel fish, and I know that I've got 10 more rainbow. And those all have to add up to 80. So the way the bar model works is, what I want to work out is what one square represents. And in order to do that, I need to get rid of this add 10 bit first of all. So I'm just dealing with the squares. So in order to do that, I have to take 10 off. And if I do that, I take 10 off the total. So I know that the total number of blocks I've got there come to 70. I've got 7 blocks. So in order to work out the value of each block, I have to do 70 divided by 7, which is 10. So each of these little blocks is worth 10. So therefore there are 10 tetra, there are 30 rainbow, plus the 10, 40. And there are 30 angel. So that's how you represent that using a bar model. Let's have a look at the second question. So we've got 106 sandwiches, some bacon, some cheese, some ham, and the rest tuna. 5 times as many bacon are sold than tuna. So if tuna represents 1 block, bacon is 5 times as many. So that's going to be a bar 5 long. 1, 2, 3, 1, 2, 3, 4, 5. So 5 times as many bacon. They sell half as many cheese as bacon. So cheese is going to be half as many, so 2.5 blocks. And they sell 18 more ham than cheese. So ham will be the number of cheese plus another 18. And I know that all of those have to add up to 106. So the first thing I do is get rid of these 18 sandwiches just to leave me with the blocks. So if I take 18 off there, I've got to take 18 off there. 106 less 18 is 88. Then I count the number of blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2 halves is 11. So each block is going to be 88 divided by 11, which is 8. So 8 tuna, 1620 ham, plus the 18, I keep forgetting the 18, so 38 ham, 1620 cheese, and 40 bacon. That's question 2. Question 3. Garage has 120 cars in stock. Some are Audi, some are Lexus, some are Volvo, and the rest are BMW. They have the same number of Lexus as Volvos, so we don't know how to represent those yet. But we know that they all add up to 120. 1/3 of the stock are Audi. So straight away, I know, in fact this is, you don't need a bar model for this one, because straight away we know that 1/3 of 120, so Audi is going to be 120 times 1/3, which is 40. Half as many BMWs as Audis, so that's going to be 40 times a half is 20. And they have the same number of Lexus as Volvo, so those must be 60. If I take the BMW and the Audi out of the stock, it leaves me 60. There's the same number of each, so that's going to be 30 and 30. So that one actually doesn't work out bar modelling, or as if you watch the trial and improvement video, it doesn't come out as a trial and improvement question either. Question 4. Question 4 is quite a complicated one to do using a bar model. I prefer this from a trial and improvement point of view, but it can be done by bar modelling, so let's take a look. Susan's purse contains 33 coins. Some are £2 coins, some are £1 coins, some are 50 coins, and the rest are 10p coins. She has 3 times as many £1 coins as £2 coins. So if we start by representing the £2 coins by one block, £1 is going to be 3 times the size. She has 5 more 50p coins than £1 coins, so she's going to take the number of £1 coins and have 5 more. And then it says there are half as many 10p coins as 50p coins. So however many 50p coins we've got half as many, and that's what makes this a bit messy. But we know in total those have to add up to 33 coins. So what we do to deal with the fraction is we double everything. We work with twice as many of everything to deal with the fraction, and that will then give us the value of each block. So we double everything. So now I'm going to have 66 coins, a double block of pounds. I'm going to have 6 lots of that. This is going to become doubled as well. So rather than 3 blocks and 5, it's going to be 6 blocks and 10. And then by doubling this one, it frees up the problem caused by that half as many. And now, because I've doubled everything, I know that that's going to be 66 coins. I just want the blocks on their own, so I have to take the 15 extra coins off, which means I have to take the 15 extra coins off that, leaving me 51 coins, and that's between 2, 12, 14, 17 blocks. So 51 divided by 17 is 3 coins. So each little block is 3 coins. So we can put that now back into the original one. So that means I'm going to have 3 £2 coins. I'm going to have 9 £1 coins. I'm going to have 9 plus 5, 14 50 pence pieces, and half as many 10 pence pieces is 7. So you can see there that that adds up to 33. 7 and 3 is 10, 19, 29, 33. And their value will be £6, £9, £7 and 70 pence, which adds up to £16.22.70. So if you've gone through this with a trial and improvement, that's exactly the same thing you end up with, but we're coming at it in a slightly different way. It's a bit more complicated because of that fraction there. Question 5. A computer shop sells laptop computers, desktop computers, tablets. They presently have 71 items in stock. So we've got laptops, desktops and tablets. And we know they're going to add up to 71. So if 1/4 of the number of tablets are desktops, so if we think that another way rather than having to deal with the fraction, that is telling us that there are 4 times as many tablets as desktops. So however many desktops there are, there are going to be 4 times as many tablets. So there's 1/4 of the tablets are desktops, or 4 times the desktops are tablets. There are 10 more tablets than laptops. So the laptops are going to be fewer than the number of tablets. So it's going to be the number of tablets less 10. It's going to be 10 fewer of them. And they are going to add up to 71. To deal with, we want to just get them boxes on their own, so we have to get rid of the 10 fewer by saying there are 10 more in total. So if we're taking off by adding, we've got to add to that side. So these in total have to add up to 81, and there are 9 blocks. So each of the blocks is going to be worth 81 divided by 9, which is 9. So that means we've got 9 desktops and 36 tablets, and then 36 less 10, 26 laptops. Question 6. In an innings, a cricket team record 33 boundary scores, which are 4s or 6s. They score 10 times as many 4s as 6s. So 6s, fours. If we have that number of sixes, this is going to be 10 times as big. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the number of boundaries, so the singles we don't have to worry about yet because we're just working with boundaries here. The total number of boundaries is 33. So the 33 boundaries are represented by 11 blocks. So 33 divided by 11 is 3. So that means 3 sixes and 30 fours. So that's 18 runs, and 30 fours will be 120 runs. So 138 runs come from boundaries. Two-thirds of the total score, so the total score, two-thirds of the total score comes from singles, and the rest of it come from boundaries. So in order to work out the total score, each of those little blocks we know is worth 138. So we got 3 lots of 138. Total runs scored 414. Okay, so that's the practice questions. So let's see if we can now go back, if I can find them, to the original GCSE questions that we were given. So a shop has 31 plant pots. Some are blue, some are yellow, and the rest are red. 4 times as many blue as red. So we'll have 1 block for red, 4 times that for blue. And there are 5 more blue than yellow. So the yellow ones are going to be represented by the number of blue less 5. And they're going to add up to 31. So to get the little blocks on their own, I have to get rid of the take 5 by adding 5, which means that the blocks are going to be worth 36. There are 9 blocks, so we do 36 divided by 9 is 4. So each block is worth 4. So 4 red, 12 blue, 16 blue, and 16 less 5, 11 yellow. I've just checked that up to give me 31, 20, 31. So that one's quite nice using a bar model. And then the last question that we're going to look at. Team A and Team B play in a competition. Team A has 9 more points than Team B. Team A has 4 times as many points as Team B. So if Team B has got that many, Team A has got 4 times as many. And we also know that Team A has got 9 more than Team B. So in order to make those the same, that many are equal to 9. And if you compare those 2 blocks, you can see that that plus 9 is the same as 3 of those equal blocks. So each one of those must be 3, and because they're all equal, that means they're all 3. So Team B has got 3 points, and Team A has got 12. That's 4 times that, and the difference is 9. So that's how you'd approach those questions using bar modelling.